Alright, so this is for FOM 11, Chapter 7, Section 3. This continues on with this whole idea of quadratic functions. In the previous videos we discovered the quadratic functions. There's certain characteristics of the letter A, what happens to the graph with letter B if we change letter B, and then what happens to the graph if we change letter C. So A, B, and C does certain things to these what essentially are called parabolas. They look like the letter U or the letter N depending on what values A, B, and C takes on. So in this particular lesson we're going to talk about this idea of what's called a zero. A zero in a function is the value of x that makes the function equal to 0 or touch the x-axis. So if we could plot these graphs, and all we want to know is where it touches the x-axis. Okay. Another fancy word for a zero is what's called a root. It says in an equation the value of x that makes the equation equal to 0, like the zero above. So the word zero and the word root are sort of interchangeable. They mean pretty much the same thing. It says here the goal of this lesson is to use a graph of a quadratic function to find the roots. Okay, so we're trying to find the x-intercepts, we're trying to find the zeros, we're trying to find the roots. Okay, so it says here, example, can you determine the roots of this quadratic equation? Use a graph. So notice on the right hand side we have Desmos, so all you have to do is just key this in. So this will be 3, and I'm going to need my keyboard. X squared minus 6x plus 5 excuse me, equals, that's just allergies by the way, 2x, and then bracket 4 subtract x. Now I'm going to blow this graph up a little bit so you can see a little more of it. So what are my zeros? What are my roots? What are my x-intercepts? They all mean the same thing, so all you do is you just touch that. So my x value is what looks like 0.42. And notice my y value is 0. That's why it's called a zero. We want the y to equal 0, but what x value makes that happen? Well, in this case it's 0.42, and then the other one is 2.38. So in my notes, all we have to do, right, all we have to do is my zeros are, or my x values are 0.42, I think it was. Let me just bring that back. Yep, and then 2.38. And that's it. Alright, so we're interested in where the graph crosses the x-axis. So moving on to the next part. It says here, the height of the water ski jumper after launching off the top of a 5-meter ramp is given by h of t is equal to negative 4.9 t squared plus 24.46 t plus 5, where t is the time in seconds. And h of t, well, that's just the height of the jumper. Okay, so this is the height of the jumper as long as you can plug in a time. Alright, if you can plug in a time, this equation will tell you what the height of the jumper is. It says here the jumper can hold a flight pose until he comes down to a height of 4 meters. How long can he hold the pose? Well, again, all we have to do is, use our Desmos feature. So let me just get rid of that graph. And it's going to be, instead of h of t, we'll just use y equals negative 4.9. I'm not going to use the letter t, it's going to be x, okay? So the letter x represents time in this case. Squared plus 24.46 x plus 5. Now, it's asking, the jumper can hold a flight pose until he comes down to a height of 4 meters. Well, here is my graph, and let me show you how to read that. At time 0, he's at a height of 5 meters. So let me just shrink this graph. And at time 0, which means at the time he took off from the ramp, he's 5 meters tall. He flies through the air. He reaches a maximum height of whatever that is, 35 meters, and it happened at 2.5 seconds, and then he comes back down, and then eventually he hits the ground, right? Or the water, or whatever it was. Yeah, water. Okay, so the jumper can hold the flight until he comes down to a height of 4 meters. Well, what we want to do is we want to be able to read the graph. Where is, how much time is it? Well, here's time 0, and you can sort of see it's the x value. He can keep holding the pose, keep holding the pose, keep holding the pose, all the way till the time he hits 4. So let's bring our pointer down, and it's going to be roughly about, I don't know, around 5 seconds. Now, how do you get an exact value where the height is exactly 4? Well, what you do is, on a second graph, you go y equals 4. And notice that Desmos will plot another line. Well, if you now find the intersecting point, it'll tell you exactly. The water skier can be in the air for 5.032 seconds, and then the height is 4 meters. So, what we do is we know that the height is equal to 4 meters, and so I'm going to plug in 4 meters into my equation, negative 4.9 t squared plus 24.46 t plus 5. Using Desmos, we figured out t was 5.0 seconds. Okay, all I need is 1 decimal place of accuracy, so it's not a big deal. Done. All right, moving on. It says here Farmer Brown wants to fence off a rectangular area against the side of the barn. He has 40 meters of fence to use. So can you write a function to describe the area in square meters for any width in W meters? Well, when it comes to word problems, things get slightly more challenging, but it's not super duper hard. So if you would agree, this is W, that's W, and that's L. Well, we have 40 meters of fencing, so hopefully you would agree 40 meters is equal to W plus L, right? Which is really 40 meters is equal to 2 W's and 1 L. Now, it says here, can you write a function to describe the area in square meters for any width W meters? Well, what is the formula for area? Well, isn't that length times W? You know, when it comes to mathematics, you know the area is what we're looking for, but you can't do math with 2 variables. It's all got to be 1 variable. Okay? So what I can do is I know that L can be written as, right, if I just kept L all by itself, I know that it's going to be 40 meters subtract 2W, right? So in previous math courses, whenever terms move across the equal sign, so what I'm doing is I'm moving it over to the left-hand side. It's positive right now. Well, it becomes negative when it's on the other side, right? So it's going to be 40 meters, negative 2W. So I know that anytime I see the letter L, I can replace it with that. So now we know L, well, that's just 40 meters minus 2W. That's the L value times W itself. And again, I apologize for my handwriting. It says here, write an equation to determine the width of an area of 250 square meters, 200 meters, and 150 square meters. Well, now it's asking, well, we know that area is really, if I were to multiply this out, right, 40 meters minus 2W times W, that's going to be, I shouldn't say 40 meters, it's just be the number 40, okay? So let me just write it out nicely. 40 minus 2W times W. Well, if I were to distribute, and this is from Math 10, that would be 40W minus 2W squared. So we have an expression for area, okay? It says write equations to determine the widths of the areas for 250 square meters. Now it's saying, hey, make A equal to 250 square meters. That's 250 is equal to 40W minus 2W squared. So what would W have to be? Well, I'm going to go back to my Desmos and I'm going to do this. I know that Desmos can't use letter A and W, so you have to use Y. Y equals 40x minus 2x squared. Okay? So A, well, that's just my Y value. And every time I see a W, that just represents X. Okay? Now, what are the X values when my area is 250? Oh, well, I'm going to make Y equal to 250. Now I'm going to ask, oh, where do they cross? All right, so I'm going to take a look at my graph, and I don't see a cross, or do I? Oh, it doesn't. It doesn't cross at all. That means it's impossible. You can't get an area of 250. Okay? I'm going to do the exact same thing. Now, it's going to be 200 is equal to 40w minus 2w squared. What is w going to equal to? Well, it's the exact same equation, but this time instead of 250, I'm going to do 200. Oh, look at that. It does sort of look like it does cross. Well, it crosses right here. Oh, w would have to be, right? W is the x value. W would have to be, let me just zoom in again. Oops. Let me just zoom in. And it looks like pretty much 10. Yeah, 10 and 200. Okay, so W would have to be 200. Sorry, W would have to be 10 meters. Now, if it was 150 square meters, is equal to, oh, let me just blow this up a little bit. 150 is equal to 40 W minus 2W squared. Another way of looking at it is you can go 0 is equal to, and let me just change the order of the terms. That's W squared plus 40W minus 150. We can plot that as well. Okay, and so let me close that up a little bit, and I'll bring Desmos back up. And there you guys are in one of my photos. Desmos, there you go. Then this goes back to finding the zeros. Okay, so my equation, if I can sort of see it, it is y equals negative 2x squared plus 40x minus 150. Okay, so now what we're doing is, instead of finding the intersecting points, we're trying to find the zeros. So W is going to be 15, or W is going to be 5. In fact, there's actually two answers in this case. Okay, so there is no answers for 250 meters. Alright, no answers. If it was 200 meters, W would equal 10 meters. If it was 150 meters, there's actually two lengths. W could either equal 5 meters or 15 meters, which is kind of interesting. Okay? And that concludes today's lesson. Thank you.